Okay, so I just wanted to show real quick kind of what the scenario is right now with this thing. So we got it powered up. We got the JA circuits hooked up. I did try, so it's a Race America sign. So I did try to hook it up to the Race America timer, which does not work. So that's interesting. I don't know if it's an output issue on this or if it needs another special cable instead of just a regular Ethernet cable. But anyway, we have that working, and we can start this guy here, and we'll stop it after, let's say, 3 seconds. So right now, it's trying to display, oh, that was 4.6. So it's trying to display 4.662. And you can see how, that's not really anything close to that. So there's a few interesting things going on right now. Not only are some segments completely out, but we see flickering right on cue. Awesome. Which is kind of neat because I don't know. That's very odd to me. I get the whole segment thing being out because of the way that these are driven. You can kind of get a cool view of some of the circuitry going on here. But don't quite get why it's flickering like that with the kind of, I'm wearing my nighttime retainer, so I say some things weird. But yeah, so I'm not sure if I'm guessing just that these transistors, let's see if we can get them in focus here. One sec. Let's find something in the organized chaos. So I'm guessing that just these transistors I showed earlier, see around that chip there. So that chip is probably just a shift register or something. And then that's just driving those transistors, which are driving each bank of LEDs. So I'm guessing that those things are just failing. I'm hoping that's the issue. And it's not some other more complicated issue. It could be a power supply thing, but again, I don't think there really is any kind of power supply other than that. And I'm guessing if we go, yeah, these don't have any components. And if we go all the way down here, what do we got? I mean, we've got to take this cover off really to look at it more, but we got that same thing going on. So yeah, so we got data in VCC. Oh, bat in is interesting. But yeah, I don't really see much power supply related in here. So I'm guessing just some resistors. Well, how many LEDs we got? We got 6 LEDs, 12 volts. So yeah, I mean, it's probably not any kind of complicated power supply. Oh, it turns off after a bit. So you got to send over a new time, which that is almost exactly 1 second. Wow, I'm like amazing, right? But yeah, I guess it's trying to display a 0 here. So these segments are out. These 3 and this one. This one's obviously out. Well, wait. It should be trying to display a 0. So all of those are not working? But didn't those just work? Okay. So the problem is worse than I thought. Because if that was just a transistor issue, well, no, it's kind of being consistent, isn't it? Let's try to do, let's think about what we want to do. So we did 0 before here. So let's just try to do anything other than 0, I guess. So we got 819. So again, just that one segment. And that time we got 1092. Okay, let's not display 9. Come on, Devin. 1074. That's too close to 9. That's another 0. Let's see what we can get here. Another 4. 7. Okay. So yeah, you can see where it's trying to display the 7 a little bit. So I was worried that it was an issue with the driver on the first digit that's outputting to these shift registers. They might be shift registers, or they might be No, I don't think it's SPI. Because I noticed we used 4 pins on the input of there, so I was thinking it's just SPI serial, 4 pin SPI serial communication. And with that, basically you can pick the chip that you're outputting to in a chain and then send the data to that one, I think is kind of how it works. So in my mind, I was thinking that it was kind of outputting to a particular one, but this is kind of a bit more complicated where we're outputting to one master kind of chip and then it's controlling the display. So in that way, I'm thinking it's kind of like how, like, if you ever built or looked into building like a LED 3D cube kind of thing, where you have hundreds of LEDs and you have one, Arduino, whatever, driving the whole thing. The Arduino doesn't have hundreds of digital or analog output pins. We have shift registers that you can use to extend those. So I think it's something like that. And then instead of using an LED driver, we're just using transistors here. And the transistors just for those segments are failing, as I was talking about. So probably not really that difficult to fix, honestly. We'll just go through and change all of those transistors, because then we got, 7 times 6 of them to replace? So that would be fun. Yeah, I was really kind of hoping to put it into some kind of maintenance mode. I wanted to do all 8s to test that, but at the moment, I don't have a way to do that. I am thinking about hooking up the logic analyzer to see what that signal looks like, but that is going to be a big project. And do you see that it has actually an animation it looks like for turning off? But I'm not sure we'll have the time. This is all done courtesy, by the way. So kind of managing my time here just to be efficient. So if we can just replace all the transistors and that works, we'll just do 1 digit to start. Probably start at this one because it's the furthest away from all of the complicated stuff. And if we get this last digit working properly, then we'll just do everything. That's what I'm thinking right now. This thing is interesting too. We're probably going to open this up and see what's inside there. It looks, at first glance, I thought it was riveted together, but they're actually Allen keys, as someone pointed out to me. So we can pop this bad boy open and just see what's in there. I think these came out in like the late 90s. It still works fine. We can pop it open and just see. I'm curious because it obviously has some, it's not just discrete circuitry, it actually has some programming in here. So there's some kind of chip that someone had to pick and write code for. So it's always interesting to see what they selected. If it's like an old 8086 or something like that. Well, we need to see. So anyway, we'll get this thing apart and cleaned up, and then we'll see if we can get the 1 digit working properly. Oh, and before we move on, just a quick view of the amazing wiring we got going on here. So we got trusty old tech power, and then we got so we got, this was given to us from the organizer. So they plug this 12-volt cigarette lighter into a car battery at the event, normally. In this case, we got to plug it into our power supply. I'm guessing they have a second one of those they use, because this is a cigarette lighter plug that's wired into the timer. So this cable is actually an adapter, but I don't have a second plug, and I don't have a second one of those, and I'm not going to cut their wire. So I mean, I could, it wouldn't be a big deal, but so we got these clamps on here. Just a fun little thing. So I got the serial cable I need. Basically male FTDI adapter to USB, and we got the timer running, and we are catting that port. And amazingly, it just writes. So I triggered a time here, which was 3.717. So we can see that the JA Tech, it outputs the times. This is a kind of fun thing. It outputs the times in reverse. So even when it outputs actually to the computer, it does the same thing. I wasn't really expecting that. So when we wrote the software, when we wrote the driver basically in the software, that's what we had to support. And the first time I saw this, I was like, how the heck do I get a time from this number? What does that mean? And I realized, oh, it's backwards. If you look at their website, JA Circuit says the times come through to the computer backwards. But I thought that meant that like the sequence of the numbers came in backwards, not the numbers themselves. But anyway, we had figured that out before, and I had known that. But I didn't know that for the display, it does the same thing. It outputs the like why is that a thing? But anyway, so that's easy. The weird thing to me is that that's the standard for this. I wasn't expecting that to accept numbers in reverse and just display them. So that's neat. So I got to remember what this delimiter is here, what the hex code is, and then I think we can just send that over the wire, carriage return end, and then hopefully the display will output that. The other thing that might happen is that this port might detect how many pins are in use and then change its output mode, which sucks for us because that will make things more difficult because it's lying to us right now versus what it normally puts out for the display. But hopefully not. So we'll hook up the display real quick and try to output this same value from the computer and see what happens. Okay, so I think I figured it out. So right now I'm rendering on the display 1400, obviously. And what we're gonna do is we're gonna send hexadecimal. You can see all the freaking trying to replicate what this thing is outputting to there. It sends this string, performance timing systems, blah 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 blah, and then sorry, I'm used to my touchscreen laptop, so we'll go up to JA circuits. So basically for like these two sequence of numbers, it sends like these bytes, and it puts x80 in the middle, which is actually not a byte, it's an integer in Java. But anyway, we can ignore that, and we can just put the carriage return on the end. And when we send this over to the timer, it does nothing. Okay, that time it's not working. But you can see that the LEDs flicker when I do that. I don't know if the camera picks it up, but they do flicker. So I don't know what's going on. Before I did that, and I saw additional line come up, and I think it was just the display messing up and some segments coming off and on by itself. So okay, we've made no progress. All right, so we've tried a whole bunch of things to try to create some way to output every segment of the display. I think we're just going to move forward with the repair at this point. I did trigger the timer at 88 seconds just to try to see what these two digits look like. You can see those segments aren't working, and most of the ones on this one aren't working. And you can see the middle there is kind of lighting up. This 2 did work, so you can see it's 88284, and oh, it's like gaslighting me. Okay, there we go. So that segment goes in and out. And I noticed that sometimes the whole display goes dim and then gets bright again. So I'm guessing that you can see more segments are going in and out. I am guessing that it's not a shift register issue because it wouldn't flicker. The voltage wouldn't flicker like that. I mean, the shift register should be on and off on those transistors. So I'm guessing some of the transistors not only are bad, but are pulling to ground and then causing the whole thing to dim and flicker. So we'll start taking it apart. We'll put a voltmeter on each of the outputs of those transistors, and then the shift register, which should be like half a volt or whatever, and then we'll confirm those are the problem. We will fix one digit, test it, and then we'll go through and do the whole thing. Just a lot of soldering, but yeah, that's what we got to do. Okay, so now we've got some time, so we can pull the back off the timer now and start getting a look inside. Did I clean up the workbench? No, but anyway, that's not going to stop us. So let's get the container here for the screws, and it's quite large, but I'll try to keep it in view here. So we'll pop this on. Oh, that's going to take a while, isn't it? Those screws don't feel like they're going to be very cooperative. Let me see here. What am I working with? What is that screwed into? Let's try this one over here. Okay, that one just came out. Let's try to, let's do this. So we'll put this thing this way, and we got 1, 2, 3, 4, 5, 6. So, all right. I'm gonna try to keep track of where the screws are going here, because I don't know what the freak that they're doing. Well, we'll see what we can do. Let's take this one out. No? No? How about the ones up here? Can we get these out? Sorry, that's not really in the view of the camera. Alright, well, let's try around the edge. Alright, so around the edge, these ones all come out. Sorry that it's not in view. Let me try to slide this. So we can get the ones on this end out. And I have a feeling this timer has like fallen off its mounts multiple times. So I don't think me sliding around on the desk is really a big concern. Let's flip it around. Get this one up here. So there was only 4 screws on the outside holding this back on. And I'm guessing that the nuts on the other side of these screws are not captive. And that's why that's just spinning like that. So let's see what happens with those out. Let's get our other fancy screwdriver here and see if we can pop that up at all. Woohoo! I'm used to entertaining a 1-year-old, so everything is woo! All right. Oh yes. Okay. Let's get a better view going here. Let me move this out of the way. So this is our container. So we'll clean this inside and out later. Let's put this to the side. Yeah. Okay. And let's get to the fun part. Oh, this is very flexible, which makes me nervous. Okay. Let's see if we can get a better view going on here. That's ×3 zoom. Is that gonna work? That kind of works. All right, so here's kind of the main. Let me just give this a quick spray in case there's any dust in here. Okay, so here's this board, and you can kind of see what we got going on down here. So here we have shift register, which I said before was MC. Actually, you can probably read it better. I can look in the camera. MC14015 BCP. These are discontinued, but that's fine because I have a giant drawer of 8-bit shift registers. So if any of these are bad, I have a big reel of these things. I didn't check the pinouts yet, but I'm guessing they were just drop-in. I think this is all Motorola stuff maybe, and mine are Texas Instruments, but that should be fine. These are what I think are bad. So these guys here, you can see that they come off the shift register and they drive the LEDs. I'm guessing those are things are bad. And if we go down the line, so let's zoom back out. We'll zoom back out. Okay, so we go down the line here. We can see the same pattern repeated. Ooh. And also, as you see, the guy was putting these together. He has the serial numbers written down. So we got A5167, A5168, 69, 70. He puts a slash through his zeros. Love that. 71 and 72. So, oh, here's an interesting thing. So we see next to the serial number, we see part 1, 2, 3, but it doesn't just keep going. And then we get another 3, another 3, and a 4. And I bet that's due to... What is different on these? Maybe the decimal places, something with the decimal places is different. Some of these have these filled in. I don't... Let me see. Let's see. Let's slide them back and forth. So we got this part 3. Looks like that. And then we got part 4. What difference am I seeing? Not really a big difference. Oh, I am seeing some interesting stuff. So look at this board here. Look at... Right, let's get the... I don't know when these things were released. 2005-ish, something around there. So we see this... let me get it better. Let's go back to the zoom for the camera. All right, so yeah, I mean, someone was working on. I don't think that the guy in the Race America factory was doing that level quality or he was really rushing it. Yeah, I don't know about that. Ooh, what do we got going on here? Is that actually our problem? I don't see that problem repeated anywhere. Sorry, I'm not moving the camera around, but no, I just noticed that these traces look very interesting. It looks like, at first I just thought there's flux spilled on them. Maybe that's it. Hopefully that's it. But we can always bridge traces if we need. That's not a big deal. This is a very simple circuit. But yeah, that first I was like, oh, someone repaired that, didn't repair it correctly, and now we're getting some bad connections. But I don't know. I don't think we're drawing that much current, so we'll see. Sorry, I keep saying we'll see and then not actually doing anything, but I'm very excited, and there's so much to look at in this equipment, which has been in use for so long. We can see it looks like some LEDs have been replaced. So at some point, someone, was trying to work in here and just replace them with some generic red LEDs. I don't know if they checked if like the draw or anything is the same as the other ones. I can definitely see that some are burnt out. They are, as I said before, in their other equipment, they have a tendency, it looks like, to overdrive LEDs. I don't know if they're not speccing their components right or anything. I mean, you don't need to drive them. You can pick components that are rated a bit higher than your duty cycle, right? You don't want to drive these 100% all the time. Obviously, they're gonna fail. You don't run a motor at 6,000 RPM all the time. Unless it's a Honda. But these, yeah. I mean, this one's obviously bad. These are failing. But that's probably not the... I mean, that could be causing the transistors to go, in all honesty. That could be a factor. So anyway, let's power it up, get a signal going to it, and get a probe on those transistors. So get the multimeter out. Let's put you here, center of attention, and we'll get these things, probes out. Am I still zoomed? I'm not. That was a bit messy. Don't look at that. Okay. This one's especially bad, so we'll look at that one. Also, it lines up nicely on the desk with the camera. So let's hook up to ground here if we can. I have a better connection off camera and ground, so I'm going to hook that up here. So we got the ground hooked up on this trace over here. And actually, let's look at the transistors. What do we got going on here? So we got a... Dust on everything. There's flux on a couple of these. So someone was in here because factory person was not doing that. Anyway, and they are the same part, it looks like. Let's kind of do here to look at those better, because my eyes are not geared to this. So we got the other phone, and let's see if I can read that. Okay, so what we got going on here is D300L. I don't know what those symbols are. I don't recognize those manufacturers. D300L. So let's look it up. Sorry, my battery is had a long day. D300L. I could probably just type NPN or something, but that did not come up with anything. Let's try the other. C94 back. What do we get here? C94 back. Man, nothing really is coming up for these things, which is really not helpful. Maybe it's O300L. I might feed, one thing that ChatGPT is good for is I can feed it something and says, hey, this looks like this. And then it's like, did you mean? Okay, so now we're actually getting at least some kind of results here. MOSFET. Some kind of animal going through the fruit outside. Well, anyway, we can kind of probably determine current draw and whatever voltage these shift registers are putting out, and just pick a component that works. I was hoping to find like a spec sheet saying, oh, this is for this, approximate current draw and, operating temperature, and then I was going to go one up and replace them that way. But that's fine. We can use math. So moving on, we're going to power this thing up, which means I'm going to get the JA circuits hooked up here. So how are we going to do this? We got so much stuff on the bench going on. See if I can zoom out, and then maybe you can see some more things going on. So we're gonna get the power supply hooked up here. So we got this thing from the organizer. So we got the center pin, positive. See, I marked it so no one ever forgets. It was not marked when I got it. I think everyone knows center pin is positive, but you never know. So that's hooked up. And then we got this guy here. We're gonna hook that up, and that powers this other equipment. Here we go. And then we will put this back over. Well, this actually has to go out of the way because I have to lift this up to hook up the connections in the back. Okay. Well, let's plug it in, and you can see the start sequence without the screen on it. The power has to be on for that to happen. So one moment, that's disconnected. Let's disconnect here, set the power correctly. About 12 volts, reconnect it. It's fun, isn't it? Okay, and then we'll hook up the data line here, which I'm still 100%, not 100% on in terms of what protocol is going on there. It looks like 4-wire SPI, but I have no idea. And then we're gonna get this thing hooked into the, can you see that? Yeah, and get this thing hooked into the JA circuits here. And then, sorry, saying is not very entertaining, but, and then we're gonna get this wire into here, and it should go beep. It's the machine that goes beep. Sometimes it goes beep, beep, beep. Okay, we're gonna go start, stop. And it's not going to display anything because it's a piece of shit. Okay, let's start jiggling some stuff here. What we got going on?
I've noticed that sometimes after plugging in the data line, I need to unplug the unit and plug it back in. Turn off the light for a minute so you can kind of. Okay. But yeah, I think part of the problem is that so many of these components are just not spec'd out to last in direct sunlight for 10 years, which, whatever. Okay, all right, so now let's see, what do we got displaying on the timer? We got 728. Oh, that's cool, we got an 8 trying to display. Okay. Let's get our multimeter up here. Someday, you know, I'll get a bigger table. I'm pretty happy to have a table in general, though. So let's get this hooked into. Why does that look weird to me? Yeah, I mean, it looks like ground, but it feels weird. Better than tasting weird, I guess. So I was just trying to see if I can get anything to flicker. Ooh, is that because I'm touching it? Okay, well, anyway, let's get this thing over here. Let's turn the, how the freak do I turn the light on this thing? That way. We got the light on. So, let's see, what's going out to our LEDs? These ones. So, 1.2 volts. Nada. Remember, this one is trying to display 8. Now let's look at what we got going on here. 3 millivolts. Let's look at a good one. So one of these up here will be working properly. Make sure my giant ass head isn't in the way. We got nothing. Nothing. What is going on here? Nothing. Nothing. No, don't do that. Stay. Okay. Well, anyway, this section is on. Yeah, this one, these new LEDs that have been put in are kind of a problem, I think. Anyway. So in this section down here, I can see that this one's putting out 1.2 volts. We only have one section that's working, kind of. Oh, that one came on. That's fun. Which one are you? 1.2 volts, right there. Let's hook that lead on there and then watch that. Yeah, we can see that going up and down as these LEDs kind of try to stay on. I feel like a volt is kind of low, you know? It's going up and down. And one thing I see here, or I don't see, maybe we should get this, oh, here's those captive screws I was looking at. Get this off and look at the other side. I think there's no resistors anywhere on here. Down here on the other end I see some. But like on this board in between these transistors and or MOSFETs, I guess I should start to call them. Between these MOSFETs and these guys, I don't see any resistor, which is kind of interesting. I'd like to know which one are these here. I have to pop open the other side of the board probably. So that one's given 1.1 volts. What have we got here? 4. Now one thing I could do is hook up the let's see here. So one that's working. Let's figure out what we got going in here. Well, working. We got a volt. And then what do we got coming into this thing in the middle? We got a volt on that pin. We got nothing on that pin. And a millivolt on that pin. Something seems weird here. So on each board we got clock, data, ground, VCC, and battery. The fuck is, excuse me, battery? Uh-huh. Let's check between VCC and these pins. What are we seeing then? Okay. I just have a bad ground. Let's try another ground. Let's go down the line to this board here. So we got a volt. Oh, okay. When this one's not displaying anything, we still have a volt on this pin. So that's, I guess, our input. But we don't get that on the other ones, do we? Oh yeah, there's a volt on that one, the input. That one has 3. This one's facing the same, 3.8 volts? Why is that one 3.8 volts? They're all running the same number of LEDs. Not that that would really, I guess that wouldn't matter. 3.8 volts. 0. And then 0 millivolts on that pin. But 1.1 volts on that pin. Uh-huh. Obviously that one's going to be 0. Wait, should be 0. What is going on? Because I can see that going right to that lead, and that's... those are not lighting up. Okay, I think we might have to take this board out soon. What the freak is going... okay, how much volt... what do we have going to the board itself? These are 5 volts. Oh wow, look at that. Look at that power supply. That's bang on. I wasn't really expecting that. And then we got whatever this is. Oh, that's data. Oops. Oh no, this one's bat in. Oh, okay. Okay. So we got the full we can up the voltage a tiny bit probably. We're not in operating voltage. Up it very carefully to 12 volts. Wow. I don't know why I'm so impressed by that, but I don't know. I expected that power supply to just be out a little bit by this point. But yeah, so we got 12 volts going to each of these, which is interesting. And we got that 12 volts going to all the LEDs directly. Right? This trace is going around to all of them. And we can see it going from this side. So we got this big heavy 12 volt trace. So we got 12 volts going in series here. Okay, I guess that makes sense. And then we're switching ground, I guess, huh? Oh, okay. So we're switching ground, which is why I wasn't reading anything really here. So what we need to do is change up stuff a little bit. So we're gonna switch over. So I'm gonna read the 12 volt line here. I think I just sorted out that thing, so it just reset. Okay. So you can do your little game. Okay, it's done. So now we can check between, actually we want to check between VCC and ground. So we're gonna hook that up here. I don't know why I didn't realize that before. I should have saw the big traces coming off of bat, and people are probably yelling at me, and I should probably be zoomed in a little bit here. Not probably too, no. But it's a bit hard to do that. Let's see, let's go to like there maybe. All right. What are we displaying? So that's a 2 on that last digit. Let's do, there's a 6. So, okay. So these guys, what do we got here? 5 volts. All right. So we got 5 volts on that pin. 5 volts on that pin. And then what do we have on this pin? Nothing, okay. Let's just go around the outside. I can see this one leads to this guy here. So we got 5 volts. So this row is powered. Really? Let's see something. We're trying to display a 6 right now. So this one should be lit up. 4.99. 5. 5. Ooh, you just went out. Okay, let's 0.8. 5. Nothing. Which one's failing right now? 5. I think we should. I think it's DAC time. So I realized it's not DAC time because this thing I threw together, my little DAC, which works up to 5 volts because it just basically plots the input pins. It's really cool because I could have hooked up all of these to all the transistors and we could have graphed it and it would have been awesome. But since everything is running off of ground, I don't have a voltage divider. So, and I'm not gonna make one at this point. So what we'll do is we're just gonna take out this board and we're gonna check and see what voltages the LEDs are actually getting. I thought this would be a lot easier than it is, but I want to double check. I want to see what are all these LEDs bad. I'm be very surprised, but it could actually be, now that I'm looking at it, that they're in series and just one of them is bad. And you know, and as I say that, I started to look at these. And I think that's actually what the case is. Anyway, we're gonna pop this board off once I find my tools. Where are the tools? There are the tools. I guess it's an 8 mil. No, that's probably too big. Is it a 6? No, it's not metric, I guess. So, unless it's a 7. Nope, it is not metric. Fun. Okay, 5/16 is too big, I think. Yep. All right, right there. Whatever the heck that is, a quarter. I don't know, let's see if the screw on the other side is going to stay there when I take these out. Ooh, look at that. They're not all the same size. Why? Okay, let's unhook our multimeter and where did the Weeha go? There's the Weeha. Don't lose your Weeha. Let's get actually we're gonna use the cheap one because it's gonna be easier to hold. So let's get these loose first. Yeah, they're all loose now. Okay. So all we're gonna do is just stick this guy in here and turn this guy, and she'll come out. Boop. Probably just hold it with my finger, actually. Yeah. Right, that one's the different one. Yeah, I'm guessing, I think now that it's just a few bad, okay, those all fell out. Let's put these in a safe place. I'll have to find replacements. So we'll get these, put those in there. And this one is a what? You are one size down, you're a 9/16. Okay. Whoop. Something fell. Looks like a plastic sleeve fell out of one of the screw holes. We'll pick that up in a second. Okay. Bear with me, we are almost there. Ah, yeah, okay. It's just there's just plastic standoffs underneath. We'll get those all out of the way here, because I don't want to lose them. Can't believe it was just series LED stuff. All the Big Clive videos I've watched, and I didn't, never occurred to me that that's the issue. Let's pick that one off of the ground. Now I'm just Big Clive with a big sign, basically. Okay, so, ooh, that's circled for me. Okay. Okay, so when they were replacing them, he was like, look at that one. And you left the big leads on there. I don't know why you would do that. That's annoying. One sec. I don't really want to get poked by these, so let's just... Oh shoot, we are still powered. It's okay. Okay, pokey stuff out of the way. So, and yes, I did just flip that board down on the other one. It's fine, don't worry about it. So, what we got going on here is the lights just flickered, so please, power, do not go out on me. And what the freak? Oh my god, that's a bad connection. What is that, data in? Whew. Yeah, this thing has had a rough life. Okay, so as we can, let's get something here so I don't F that up. Okay. So exciting. We can safely put 3 volts into each of them and figure out which one is bad, and then go from there, I guess. Well, not 3 volts, because it'd be about 2 volts we need. Okay, so we're going to turn off the JA circuits. We're going to unplug everything. We're back to working on this thing, and I know it's hard to tell, but I did clean the bench. As you can see, there is space for a drink. I removed all my meters from here, which removes some clutter and also street cred, unfortunately, but they are now, all that crap is in here, so some more room. So what we're going to do is we are going to, I think to speed this up, because the first strategy was not working, we're going to unbolt all of these, and then we're just going to set up like, flip them over, do like an assembly line kind of thing going down, just marking them all, and then we'll do the same thing, just going down and replacing all the bad LEDs, and then we'll be kind of done. So let's get to doing that. All right, found my 3/8 to 1/4 inch drive here, so what do you think we should just zip through these pretty quickly? Alright. We'll take these standoffs out. I just don't want to lose all this stuff, so we're going to make sure we remove it all, put it in storage. Okay. Slide her down, do the next one. Okay. Alright, so some of these are going to be a pain in the ass, so we're going to need to prop it up. Which makes the video a bit less interesting, unfortunately. But maybe I can do this in a way. Let's take some heavy storage items. Prop them up. No. 1 second. 1 second. Hey, all right. And then we'll need a screwdriver. Grab a stubby. Whoop. All right, now we can make quick work of these. Hello? Okay, we're gonna grab a better screwdriver. Here we go. Can smell the ozone from the drill. I noticed this drill. Ooh. I noticed this drill is sparking a little bit inside. I don't know if the brushes are wearing out or what. It should be brushless motor, right? So, and armature inside is just wearing out. I've had those drills for like 10 years. So. I don't know if Rigid has changed. Oh, you can't see shit. I don't know if Rigid has changed those designs or what, but those drills have lasted a long time. Okay, moving down to the next one. Okay, that one's getting pain. So let's get these 3 standoffs that fell off. Those over here. And then we got this one sticking out here. Okay, move it down. I doubt many are bad on these first few, but we do know some are bad, so we'll fix it. And what we'll do is we'll just take these off, and then we'll flip them around, and then drop the screws on the floor. Where'd it go? Where'd it go? Where'd it go? Okay. There it is. Make sure this is the right one. Yeah. So we'll flip it around, and we'll keep everything soldered together because that will save a lot of time. It won't really hinder us at all, hopefully. The only issue is it's going to put some strain on those joints, but that's fine. Should be fine. Last one here. This thing's going to try to move probably when I get this off, so we'll move a little quickly. And actually, I think this one might have more come out of the drill. Nice. There we go. This one might have some more things holding it on than the other ones. Just a couple. Ooh, camera's running away. There we go. There should be a couple in here. Don't see them. Oh, okay. All right. Let's just get these into storage here. Are the standoffs a different? Oh, those standoffs are a different length. So let me just let's just sift those shorter ones out here before I forget. I put them in and then I realized that they were not the same. Come here. Come here. Come here. There we go. Yeah, so, oh, that was not really on camera. So these four for this section are a different length because of this plate here. So, good to know. Okay, I think these are stuck in here because they go, oh, they're not really. Uh-huh. Look at all the dirt here. And there's this plate. I was wondering what this plate is before, and now I can show you in a second here. If you can't already see it. Let's get this out of the way. Very gently. Okay. So here's the back of the board here. Not very... That was the drill. Not very interesting. Put this down to the side. Okay. Put the fancy screwdriver away. So here's our main board here. This is the first board that kind of controls everything. And let's see if we can zoom. So some interesting stuff going on. So we have this connector which has been glued on. And I guess they didn't do that way from the factory. Yeah. And then we have our port. And then we have some configuration. Oh, some configuration. What's that for? What's that for? That would be cool to figure out if we could look up the manual and see what these mean. Because maybe that's why it did not like our output from the computer. Well, we already broke off one wire here, so these connections are no bueno. So we'll redo those. So we can see where the power is coming in. We have the power coming in down here. Yeah, battery and ground. And if you do look at that, you can tell that someone has been there. Just the way that there's like corrosion on those pins. It doesn't look like all the other pins, all the other solder joints. Anyway, let's move on with the work part. I got only the finest in Chinese LEDs, although they do a really good reviews, so they should be good. 5mm red, 2 to 2.2 volts at 20 milliamps. I am guessing that's thereabouts. Based on the voltage I read, that should be what we're looking for. So let's get this on something. So what I'm going to do, this is empty, good. Clear off the vents so we're not carrying stuff over the edge here. Zoom out. Zoom out. Okay. And let's gingerly flip this over. All right. And my hope was that I could just set this in this box and then I can desolder them one at a time that way. And also, well, let's take these out. I can use this as a rig to test the LEDs very quickly. So we're making a small time investment, and then we should be able to just zoom right through this, hopefully. Okay. Because I'm not going to be able to see. I guess for testing we can do this, and then when I'm actually desoldering, I'll put them in the other side. So turn the light off. Turn the light on. We're gonna figure out our power supply setup actually. So we got this guy going here, this guy going here. We get our pokey 3-volt leads. This is gonna go to power supply. This is gonna go voltmeter. Okay, so we got the Poke Boys here. Put those over there. Get the amp probe. Got the amp probe. Maybe we zoom out a little bit more, huh? You can see a little bit more that way, maybe. So get the voltmeter set up. Get the voltmeter on this guy. And we're just gonna kind of do this with the voltmeter. Put these over here. Fortunately, I don't have leads that can go directly into the power supply. So, yeah. All right, so we got this and then other negative guy. We're gonna turn the power supply on. And we got 1.7 sparkies. Let's take it down to around 2 sparkies. Okay, so we got that set up properly. Power supply has an analog output, which isn't quite as accurate as I'd like for this kind of stuff. All right, so now we can continue our testing. So let's find, so the battery line is our big trace, I believe, right? Battery in. So we see our battery in going around here. So I said this was one of the bad ones, I think, right? Let's just recheck our work just to resume. So that one was good. These ones were bad. That one was weak. That one was good. All right. Let's go down this row here. So what we see is so this is our battery trace right here. I think that's our battery trace. Yeah. So this is our battery trace. That's a good one. That's a good one. That's a not so good one. Where did my marker go? Hello, marker. Okay. And then we can probably zoom the camera back in so you guys aren't like out in the middle of nowhere. Honestly, we can probably do 3 zoom. I am sane, I think. This bottom segment here, we gotta think of a strategy. Strategy is clockwise and then middle segment. That should get them all, right? Oh, and then we have the 2 over here. Some of them have 2 over here. So clockwise, middle segment, dots. That's gonna be our strategy. So, okay. Got a good one. Got a good one. Got a good one. Good one. And a pin. So, is it the board? No. All right, so that one's bad, and that one's dim. So we'll do those 2. So this one and this one. Okay, then we do the bottom side here. I already had marked this one as bad. Is it just dim? It's a little bit dim. We can replace it. That one's definitely dim. That one's fine. That one's really bad. And when they don't light up, then I question myself. I'm like, is this one wired differently somehow? But it shouldn't be. That wouldn't make any sense. Okay, so that one, bad. I know I said I wasn't going to do big ugly circles, but then I realized that if I mess up and miss one, then my life is terrible. So I'm not going to do that. So that one's dim, good, weak. All right. Now we're going to do this segment. That's pretty weak. Weak. All right, so weak, weak, dead, dead. How's that one look? That one looks effed. So really, these ones are both dead. Dude, what did someone do to this thing? The one I marked before was actually the best out of all of them. That's fine, whatever. So this one's bad. All right, so we're gonna say bad, good, bad, bad, bad. So bad, good, bad, bad, bad. Now we're gonna do these outside ones here. Bad, 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 good. I don't know why I just don't do them all at that point, jeez. What's up here? Oh, I got two more. This whole, like, the leads getting tangled thing is getting old real fast. All right, so. Good, bad, bad. Double check that. Good, bad, bad. Okay, now we move on to the next board. We are not going to do any desoldering until we kind of quantified that work. And this one, well, this one does have the 3 digits here on the end. So actually, before I forget, I'll just do those real quick. So this should be our ground. Oh wait. I think this is our ground actually. Yeah. Okay. Good. Good. Meh. Really? Are you bad? There's no way. How are you bad? All right. So we said this one was meh and this one was bad. Sorry, kind of boring, but this is what it looks like. So, camera's going. All right. Bad. Okay. Bad. Bad. Okay. Good. I'm gonna say it's good. Good. Bad. All right, this one's bad. So we'll definitely mark that one. These ones are kind of like alternating good and bad, so I don't want to forget. So let's say that one's bad. That one's good. That one's kind of weak, so we'll mark that one. That one's pretty weak. That's good enough, I think. And that one's good. All right, so we got a bad one. I'm just gonna leave the marker open and not put my freaking giant ass head in the camera. So bad, bad. Let's see, weak, bad, weak. Really? I just like checking my sanity. Yeah, so all right. So this one's good, I guess. Bad, weak. right, so these two are bad. And then everyone except that one in the middle, right? Yep. Now we do the top row. See, that's good enough. That's reasonably good. Nah, we're gonna say that one's weak. Weak, 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 weaker, weakest. That's kind of a cool example of how these failed, it looks like. I don't know, I mean, the current should be even across all of them, right? But they're clearly failing more in that direction. This is our only good one. That's triggering my OCD, but we'll just ignore that. Okay. Good. Nope. No. All right, so you are bad. You are bad, so we're gonna go bad. Bad, bad, bad. Ridiculous. Did I test the center segment of this one? I did. I didn't, did I? Bad, 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 bad. It's just all, they're just all bad. Okay, okay. Nope. Nope. That one's okay. These ones are kind of okay. We're gonna say that one's weak. Okay, am I just gonna end up replacing them all? Is that what's gonna happen here? That one's good enough. Bad. 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 So bad, 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 meh. Those are all bad. Okay, let me check this portion here. Nope. Am I just not penetrating the conformal coating? Is that what's... I don't think there's really a coating on that. Shh. Yes, we know you're on. Thank you, Amprobe. We didn't forget about you. You're very special. That one's kind of okay. I'm just like really paranoid. Like, am I not just getting to the pins? Are they all that bad? No, they're all that bad. So we got one good one right here. Honestly, how good is it? It doesn't look good. So again, a whole other row that I'm just gonna write off. I don't know if there's a way to clean off this marker, but I don't think anyone else is gonna come in here after me. I really don't think that this board's gonna last that. I'll give it another 5 years. All right, so this one, nope. A little bit. What a piece of shit. Okay, whatever. Like, really, you can't just stay on? Your battery is fully, anyway. That one's kind of okay. I'm just gonna replace them all. Wow, pretty amazing. Okay, let's try not to drag. To redo all these solder joints on the wires too, probably. Okay. I put my leads down over here. So, starting clockwise after the dots. Let's check the dots. Always check the dots. Okay, bad, great. So those two are bad. Saves me a little bit of work. Good. Nope. 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 Yes. We got a good one. Woo! Good. Nope. 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 Yes. All right, so all the middle ones are dead. So all of these are dead. All of you are dead. Nope. 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 We can probably zoom in a little bit, maybe. Not 10 times. Thank you, Samsung, for showing off, but we're good. Okay, we know you have a big camera. Okay, so nope. 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 Those are all way too weak for me to be happy. No. Nope. Nope. Let's try to stay in the camera. I'm sorry. I am no expert at this camera shit. Nope. Nope. Well, that explains why the display was so unreadable. We're going to zoom back out for the top portion. Nope. 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 Nah. That one's actually good. But we'll just do the whole row. I'm getting into F it mode now. I knew this would happen. I knew this would happen. I was to replace everything. It's gonna happen. Nope. Nah. Nope. That one's okay. Nope. 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 It'd be a lot easier to circle the ones that are good at this point. That one's actually good. That one's good. That one's good. Nope. So we got a bad, and then from the other end we got those two bad. So just the two middle ones are good. And then this whole section was bad. Okay, next one. I know that sounded really messy, but it's okay. It's okay. Okay. Meh. Not great. Not good. Nope. 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 These ones are lighting, you know. But like they are, that one's okay, kind of. That one's pretty okay. I'm just gonna do all of those ones. They don't look great. Because I've seen ones that are bright is the problem. I've seen, let's grab one of the new ones. Okay, I believe the long lead is the positive one on these. I got 100 of them, well 200. So if it was under the board, it'd look like that, just from my reference. And I'm undervolting them right now just to make my check a little bit safer. I'm running at 1.9 volts, it goes up to 2 or so. So, yeah, I mean, that one's kind of okay. That one's kind of okay, but I'll just do that whole section. I think that one's okay. That one's really okay. That one's dim. Nope. All right, so what do we got here? So we got bad, good, bad, bad, good, bad, bad, good, bad. Bad, good, bad. So bad, good, bad. Bad, bad. We'll say that I'm saying them bad because they're weak. So we got bad, 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 bad. That one's kind of okay. Did I check these ones? I don't think I checked the dots yet. That one's okay. Bad. Okay. See, you can see the difference, right? Like, this one, which I thought was okay, and then you get to this guy, and it's like, woo, I'm here. So we're gonna do these two. Bad, 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 bad. I mean, that one's pretty good. Bad. All right, we got one good one in that section. So we'll just wipe out the whole area. That's kind of how the CIA works, I think. Can you see the camera? Yeah, all right. So, let's see here. I got, that one's actually lighting up, but it's very dim. Yeah. Bad, bad. That was pretty good. That one's okay. That's okay. That one's really good. That one's good. So, I mean, really, the only good one here is this one. The rest are bad. And this one was good enough that I will leave it. Because the other ones seem to have taken most of the current draw somehow. Because they don't run effing resistors on each of them. And I really don't like signs that do it like this way. It's just lazy. Okay, so let's It's weird because you would think they would be reversed, but they've actually flipped the LED around, so it's not. All right, so bad, bad, good, bad, bad, bad. So we just have one good one here, which is that one, this one. So we're gonna do bad, bad, rest bad. So 2 and then 3. So these 2 are bad. This one's good enough that I will leave it, save me some work. Okay. Bad, 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 good, and bad. All right, we'll leave this one. This one's fine. We're gonna mark 3 bad and then 2 bad. Okay, no wonder this thing did not light up. Bad, 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 good. Sorry, I think my hair was in the camera again. Bad, 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 good, bad. So we can skip that one. That one's really happy. That one's like, I'm ready to go. So we got 4 bad and then 1 bad. And then we got dots on this one, don't we? Up here we do. Bad. These 2 are pretty good. This one's not. I'm surprised there isn't any dots down there. Are they up here? They are up here. Because we got the colon. Did I miss a colon? Testing the colon. Always get your colon tested. Okay, let's get this one. That one's kind of iffy. That one's good. These 2 are pretty weak. But are they weaker than this one? Yeah. Shit, what did I say was bad? So just this one in the corner is good. And then these two have taken most of the work there, I guess. Okay, we're gonna go down this row here. Bad, 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 bad. Wow, the more you know. You see one guy was in here and he's like, this one LED is bad. Yeah, I think more than that have failed at this point. This one's good. That one's bad. 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 Good. Yeah, we're gonna say all these are bad except the first one. That new LED that they put in is it's not very bright, so we're gonna put a different one in. Bad, good, good, bad, bad. So the good ones here were this one and that one. All right, so we got 2 bad, 2 bad. 2 bad, 2 bad. I think that one's pretty okay. I'm gonna replace it. Replace that one, bad, 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 bad. That's kind of okay. That's a maybe. Bad, bad. That's pretty good. That's pretty good. Bad. Really? Can't get my... Alright, so we got bad, good, bad, 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 bad. Let's do this whole section. They're all kind of iffy. Which I'm very surprised about. I wouldn't expect this digit to light up that much. Maybe it's always displaying 0. Bad, 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 bad. Good. I almost forgot the so we got 2 colons here. So you got bad, bad, and fucked. Okay, and then over here we got okay. Alright, I think these ones are all due for replacement. Bad, 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 bad. Bad, 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 bad. Good. So good, bad, good, 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 bad. All right, so we're gonna do bad, good, 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 bad. That's kind of a meh. So we're gonna do these 2. We're gonna place these 2 here in the end. And this first one. Bad, 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 bad. Oh. That one's pretty weak. Bad. That one's kind of okay. Bad. So we got bad, good, bad. Oh, that one's really good. Alright, so the one before I said was good was not good. This one's good. Alright, so the only good one here is this one. And then, so we got 3 good, 2 bad, or 3 bad, and 2 bad. Okay, so we'll let's put my cap on my marker here. Wherever the cap is, because I've had this marker in the toolbox for like 10 years, so I'm not going to replace it now. Power supply off. Okay, and let's get this laid out on the bench, and then we'll kind of see what the damage looks like. Okay, well we can basically see why this thing was unreadable. We can go through afterward and kind of count them, how many bad LEDs there are. I'll do that after. But, wow. Here's a question. Are there any segments which are good? This one, I guess. This dot on the display is really good. This line I think does light up. Just these ones are weak. But in terms of any that I found any segments I found that didn't look like they were about to go, if not already. Yeah, none of them. They're all bad. Is there a dot here that I test? No. I'm gonna double check that one. I'm like, did I even test that? And no, that dot was not bad. They were all bad. So no, there is not a single segment on the display. There's not bad or failing. So we got the soldering station up at 650 now. We got the fan running. I realized as I was going through and testing these that my standards went up because I had seen more and more bright LEDs. And I went through a second time off camera, and all of the ones that I thought were good before are actually bad. So we're just gonna do them all. Ooh. So we just got this, and you'll notice something that this is already done, but it was not done with this. So I had just bought this which is a desoldering gun, if you don't know, because I was using this guy, and it was taking forever. Some of them, I could do in like 20 seconds or so, but that's a lot when you're working with, you got 290 LEDs to do. So I'm gonna jump to that right now and show you why I cut that out. And just keep in mind it was 95 degrees in here, and it was taking way too long, and I was hot. So one reason I'm cutting it out is because I think I was just getting a bit frustrated, and it probably swearing a bit more than I needed to. So we'll show you that right now. Most boring video on YouTube. We got a segment done. How long was that? I wasn't timing it. I don't really want to know how long this is going to take because it's going to be a while. So we got one board done. Now we just got to go through and do all the rest. So I want to power through this, and I don't want to make you sit here and watch for 2 hours while I do that. So I'm going to put music on, and I'm going to go through this really quickly, and then we'll just kind of speed through it in the video. So we'll just do that now. Okay, we got the Hiko warmed up, so we're going to go through, and first we're going to separate these boards, and then we're going to pull all of the old LEDs off, and then we'll go from there. This board, we've already added the new LEDs, so this one's good, except this LED here, which I did badly, so I'll probably redo that. But yeah, we're going to go through and redo them all now. All right, well that's it. So these are all separated now. So now we have all of these to do. So we'll kind of work on these individually. I think we're done tonight because this desolder iron is kind of loud, and there's a door directly to my neighbors, kind of. So this is yeah. I think next we're gonna do the LEDs. That was what, 5 times, so how long was that video? 27 minutes? So 5, 10, 15, 20, 25, 30 connections we just did. Not too bad. And that was including time of cleaning the thing and stuff too. So, okay, on to the next step. Here, here, here. There, 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 there. No, no, there. Right here. So. All right, so we got all the boards prepared, cleaned up, about 300 LEDs replaced. So what we're gonna do now is we're going to take our 22 gauge wire, which should be good. This is silicone wire, so it can handle a bit peak higher temps than the old stuff that was in there. If every LED is on at once, technically this whole thing could draw 6 amps. It only has to really do that for a very short period of time. So 22 gauge wire I think is good. Most times it's going to be drawing an amp or two at most on the very end. So this seems like a good wire choice, and it's also nice and flexible to work with. So we'll do lengths of about that long, just to be easier to work with, I'm guessing. And we'll go ahead and we'll start hooking these together. Okay, so that closes out connecting all the boards together. So we're going to go ahead and switch camera views, and we're going to power this thing up, and we'll see what segments are still not working. All right, so we got the power supply set at 12 volts, so let's power this on, and then we'll see how this looks. Woo, looks good. Looks like one is out. Let's check that again. Those two. Yeah, looks like these two are not working. So let's, oh wait, just lit up there at the end, didn't it? Let's check it again. These two, right? Yeah. Oh, it's trying to say ready. Okay. Anyway, let's just take a quick look at connections here and confirm there's no what the problem is, and see if it's the MOSFETs or the LED, or the solder joints. All right, so I got the board flipped over. I will say with this new wiring, it is so much easier to move the boards around. Obviously, you want to be careful you don't put too much strain on the joints, but silicone wiring is awesome. So we're just gonna probe these guys here with 12 volts, and then we'll try to see where the issue is. I think our trace right here is our battery input. Yeah, so we'll put a positive here, and then we'll check and see what's up with that. So this one's bad, and then let's see, we have this one is bad. Ah, right here. Okay, so we gotta fix these two connections. So we can probably do that just in a couple seconds here, actually. So do this, do that. Oh, let's turn on our fan so I don't get drugged up here. All right, so we're gonna get this warm. Okay. So now let's see. So positive is this trace, and then we're gonna check the bottom section here. So this is the side going back to the driver, right? Yeah. All right. So now that one's good, and then the other one was up here. So okay, let's debug it. So then we're gonna have the voltage down to 6 here. All right, so we got 12 volts coming into here. I'm gonna ground this trace. So what? Let's go down to 4 volts. And I usually put the multimeter in the view here, but you can't see it. This is helpful for me too, actually. So 4 volts, and then so I got these two lighting up. So this one's having trouble. I think it's that connection there, actually. Just wasn't very good. All right, back up to 12 volts here. Do this side of the MOSFET. The whole board is lighting up. Very weird. I wonder if that is bad. Let's go down to 6. Volts. No, that connection's still bad. Is it the connection or is it the LED? I think it's the LED. Actually, we can test that easier. We're going to go down to 2 volts here. No, the LED's good. Okay, the connection is still bad. All right. That one's just being tricky. We'll just redo that. What can you see here? All right, so we're gonna zoom in. And this equipment's not super sensitive, so I can usually just get away with adding solder. Okay. Let's bump it back up to 6 volts to test that side of the circuit here. So we got positive trace here. I got this side. No? Hello? There we go. Cool. Now we're gonna go up to 12. Put the 12 volts here, zoom back out. Okay, and we got battery out, battery in. We got the side of the MOSFET here. Ah, look at that, we got it working. Nice. All right. So now we'll do a test of the whole thing again. Okay, I got power supply set to 12 volts, so we'll flip that on. Which you, by the way, if you're using a variable power supply like this, you should probably turn it on and then connect the circuit, but it's been pretty dependable. So anyway, we're gonna flip this on and let's see. All right, that looks good. I think I saw one bad down there. Hey, it says ready. Look at that. We had no idea what it was saying before. This one is not in a good way. So let's just double check. I think this board. Yeah, okay, so this one is bad. So we'll debug and fix this one, and then I think we're done. All right, so for this one, it was just one LED that I had missed a pin on. So let's power this up on, and one final test here. Cool. I didn't see any missing. I'm gonna double check the video footage to make sure I'm not missing any segments. And then, ready, woo! Yeah, and then we're gonna throw it in the case and clean up the case, and then this should be good to go back to the organizer. Okay, so to wrap up the Race America sign project, this organizer here, what we're going to do is kind of just prevent a slight overvoltage situation. Now the sign, I guess, is like 25 years old, so it has lasted a while. I don't know how many events they did powered this way. I talked to them and they said that normally they plug it into the generator's 12 volt out. So maybe it's regulated well, maybe it varies a little bit. They also run the JA circuits timer off that, but the JA circuits might have, most likely has a better regulator inside. I mean, the chips inside that are not going to be running off 12 volts, going to be running off 3.5 or 3.3 or 5. So there will be some regulation in there for the important bits. Whereas our sign, we don't really have that. We just have regulation for the clocks and shift registers and stuff. We don't have regulation for the LEDs. So what we're going to do, since they're running off a generator anyway, is we're going to swap off this end here with just a 12 volt adapter here. And this is 12 volt DC, right? Not, it would have to be DC. It doesn't actually clarify, but I'm assuming that that's 12 volts DC. And we're just going to test it real quick just to make sure the adapter is good so we don't fry anything, even though he says even though it's technically new. We're just going to double check here. So it comes with this little thing here. I like these. I have a couple of these power supplies, 2 amp ones, 6 amp ones. They're good for all kinds of stuff. So anyway, plug our little 22 gauge wire in here and try not to be messy. And we'll hook up the voltmeter here, and we'll see. We'll also see under load what this power supply drops to. I want to make sure it stays at around 12 volts and doesn't go down to 11 or anything weird like that. Because if it does, then it's junk, and we're not going to use it. Okay, this is frustrating. Just want to kind of. I was trying to do this kind of quickly, but it's really not cooperating. What is your deal, huh? What is your deal? Do you want a thicker gauge wire? I guess that's just as far as I can put it. That's okay. If it shorts out, then we're doing a load test. That's what we'll say. Okay, so first off, let's just get the old meter here. I'll put this guy on DC, and we'll and then we will let's see, we've got this positive here. Positive. We're gonna do that. DC. And then we got this one here. And we're gonna do that. And then is it gonna explode? Is it going to explode, or will something we buy actually work? Oh, that came out. I'm like, it doesn't work. It still doesn't work. Okay, what am I missing here? DC. This one's connected, right? This is plugged in. This is plugged in. Ah! The entire desk is off. Okay, so power the desk on. There it is. Whoa. 12.7. You're not a 12 volt power supply. You're a 12.7 volt power supply. Interesting. I also liked that delay there before it came on, so we know that this is some sort of switch mode power supply, and I don't know if it has good capacitors in it or not, but it took a second to charge up. Okay, well at least it's predictable. All right, so we'll wire it into our adapter here. So let's Let's see. So we got, this one was the positive one. I just took off the meter. I'm checking this, but obviously I just took it off the red lead, so like. Okay. Well, that's why it's good to check. I mean, like, for example, that generator might say 12 volts out, but the generator might vary up to 13 or 14, you know? And, like, what's a 10% difference or whatever? That's actually kind of significant for us. This bearing almost on 13 volts kind of makes me a little bit nervous, but I think that's fine. At 13 volts is still under 2.3 volts per LED. No. So 2.1. So we're still within operating range of the LEDs. Okay, we'll hook the meter up here just to make sure it's not going to do anything weird before we plug it in. Just one last time, because we don't want to have to redo the sign again, except doing all of this clock circuitry. That would not be fun, and having to reprogram the sign with our own custom stuff. Not something I want to do. Okay, so we got this plugged in, and we got 12.7 volts. Lovely. So we got the display, which is not plugged into the timer yet, so let me do that. Okay, so we're gonna plug this in, and I guess we'll just watch here. We'll watch and see what the voltage does as the sign animates, which is off screen. That's all 8 digits right there. .6. Yeah, I think that's good. I'm pretty happy with that. Yeah. I wonder what the isolation's like on this power supply. We don't have to worry about that. Yeah, so I guess we're good. We're gonna wire this in now. So unplug this stuff. Yeah, I got some big capacitors going in there. Okay. So what we want to do is take this out. I believe my screwdriver I put back in here, did I not? Where did the screwdriver go? This is not very interesting to watch me search for a screwdriver. Okay, my Weha screwdriver went on an adventure here, so we gotta find the screwdriver. Okay, I guess we'll use this one, which just might be too big. It just barely fits. Where'd it go, though? Is it just... Ah, here it is. Hiding in the mess of wire that I should have cleaned up. Okay. I'll do this setup so that way they can unplug it if they need to. I don't know. So we're gonna take this cable, and first we'll see if this cable has any damage in it. Then we'll cut for the damage. It looks okay. So we got this thing here on the end. Well, I could just give him this whole section back. I don't know if he would want like extra cabling or not. How long is this? How long are you compared to you? We're just gonna drag this off screen. You are shorter. Okay. Okay, so then we'll just give him like this amount. Boop. The side cutters are kind of dull. And we only want a tiny bit. Which one was positive? Right. Right. Okay. Let me look at the sign real quick. So battery is the upper pin. Ground is the bottom one. And the upper pin is on the curvy end. So we'll just continue acting professional and act like I didn't forget to take a measurement. So we said the curvy end was a positive. Just make sure it's working. Yes. Okay. So this one is a positive. So let's see if we can mark that somehow, huh? That'd be cool. We can mark it. Let's just set you in that so I can find something to mark it with. I really wish I had red tape still. I don't know what happened to all that. But we do have red markers and we do have white tape, so. This will be sufficient for now. Just for future nerds that break the setup and need to hook it back up together. Okay, I think that's good. Put that away. And then we will triple check. So our voltmeter up here. And we said the curvy end was positive. Okay, it's great. Let me just double check the sign to make sure I didn't. Yep, that's the curvy end. And then we'll double check on the board. Just to double check. Yep. Okay. So we are good to continue. Nothing bad just happened. Get this crap out of the way. Get this out of the way. Get this into the way. And you know, we could crimp this whole thing together, but it's nice being able to adjust stuff and I think this will be a good connection, about as strong as crimped. Okay, maybe not as strong as crimped, but pretty close. Pretty close. And this thick cable fits in this connector pretty nice too. I'm liking that. We could actually heat shrink the whole thing to add some strain relief. That's a good idea, huh? Heat shrink? That'll take us a minute. And I have minutes, so maybe we'll do that. One thing I did not verify is that these labels are actually correct. Did I verify that? I did verify that. Yeah, we're good. Sorry it's not sounding super exciting, but I gotta like double check everything because it's not my equipment. So, okay, so we'll move the camera. Okay, so we just plug this guy in here. I will clean up this rat nest of wiring. It's just I have like 5 timers in here right now. So anyway, we're gonna let's set up the power supply. Sorry, not the power supply. The meter, kind of in view with the camera. Wait, no, that's not it. That's not it. That's the thing. That actually looks worse. Okay, whatever. So we're gonna plug this in here, and then we're gonna watch both of these and see how that goes here. It is not going because the sign is not plugged in, and this is not plugged into the. Oh my god. Okay, so we got the AC adapter wired in, so we'll just turn on the bench here. Hey, okay, cool. Okay, and now we're just gonna find some heat shrink to put over that connector, and I think I have some big heat shrink sitting around somewhere. That's not big enough. It's kind of bigger. Why do I have just a bunch of that's a last resort option. I should have some long ropes of heat shrink sitting around. Okay, well, maybe not. Maybe we don't have any long... Oh, here's some heat shrink, but that's not what we want. Okay. Huh. Neat. Okay, well, we can... That's not going to be useful. Well, strain relief doesn't matter here because if it gets pulled on, it's just going to unplug. So built-in strain relief. Okay, so anyway, we have this power cable now. And we'll give this new thing back to the organizer. And I guess we do a final demo with the timer hooked up, huh? And then they'll end the video. And of course, we got to get the shot of the circuitry from inside the board with some cool music, right? No, we don't do that here. Okay, so let me get the timer out. Okay, so what we got going on now is we got the sign hooked up with its new power cable. We got the JA circuits hooked on the tech power here, 12 volts or so. And we got this thing happily running. The sign is already running. So what we're going to do is we're going to do a start and stop on the timer, and we should get a time over here, and then we are kind of done with this project. Woo! Oh yeah! And we look over here, we got 2.1. Get out of here. 2.177. I did clean up the mess. You see, this is just all the cables required to run this thing. So just for extra effect, we'll just turn some of the lights off here, and we will. Can I put the camera maybe on the rally car? Can I put the camera somewhere? Let's grab something heavy, set it on the hood, and very professional camera work. Oh yes, very professional. Yes, maybe? And we'll just run through some times here. do 8 something to test the other digits. Woo! 8253, you can read it! I get a little too excited over when stuff works. But yeah, so there we go, and we can do a couple more. All good to go. So this can go back to Brent and competitors, including me sometimes. We'll be able to actually see our times when we cross the finish line. So awesome. I do see that a couple of the LEDs are not perfectly straight, but that's what you get, I guess, by doing things by hand. If I was repairing a lot of these, which I may in the future, we'll be making a jig so we can do them kind of factory level precision, but from far away, you know, from 100 feet away, I think it will look pretty good. There's also some effect going on from the camera. But yeah, so I think we're good to go. Thanks for watching. This was probably a long video. I haven't edited it yet, but it's going to take a lot of hours. It's like 20 hours of footage or something nuts probably. So thanks for watching. This was a fun repair and look forward to doing more. Ooh, mysterious hole.